Hi everyone, my name's Chelsea and I'm part of the events team here at the Institute of Materials, Minerals and Mining. Thank you for taking the time today to join our webinar delivered by Denise Olson. Before we begin today, I'm just going to run through a couple of house rules. If you do have any questions at all at any point during today's webinar, either for Shawn or Rob, or any technical issues, please just send those into the Q&A box that you'll see on your screen. And finally, we will be sending a recording out of the webinar in full to all attendees after the event. So if you do have any connection issues or need to leave, you will receive a recording in full. And I'll hand over to Shawn now, who's going to deliver today's webinar. Thank you.
Thank you very much, Jenny. Wow. Good day. Welcome to everybody. How incredible is this today? We have people from 44 different countries spanning every continent with the exception of Antarctica. I would say this is similar to a United Nations assembly, but perhaps we could get a little bit more done. We also have one person from Ascension Island, which for those of you who do not know, is in the middle of the South Atlantic between Brazil and Africa. In the numerous presentations I've given throughout the number of years I've been doing this, this is a first, so welcome. I want to take this opportunity to say thank you. What a great honor it is to be a presenter today. And I want to personally thank all of you for taking time out of your day to attend this webinar. You know, with all the things that are going on across our globe, I think that a little bit of a distraction can be welcome. At least it is for me, even if it is only for 1 hour. With that, allow me to introduce myself. My name is Shawn Byrd, and I am the technical manager for Denise Olson, a machine testing manufacturer or a multinational company where my primary focus is on materials testing and the correct application of the various international standards that will assist in the evaluation of different materials and the products that these materials go into. I am also an ASTM subject material expert for materials testing, focused primarily on alloys and materials that go into different aerospace, medical, and a number of different other products. I sit on 5 different ASTM committees, and I have been involved in testing labs across the United States, the United Kingdom, China, India, Singapore, and Mexico. And today, with your input and participation, we're going to unfold this ever-changing world of standards development. I will now pass off to my colleague and co-worker, Robert Thorpe, who's located in the United Kingdom. We may be having a bit of a technical difficulty. Are you with me, Robert? Robert?
Good afternoon. Sorry, slight technical issue there for a second.
Okay, you're on?
Yes, I'm back now. Terribly sorry for that, everyone. Hi there. Yes, I'm Robert Thorpe. I'm a design engineer at Denise Olson. My role there is the design of grips and attachments for the up to 300 kilonewton machines. These range from furnaces to medical, concrete, textiles, and pretty much every other thing in between. That's what I generally do. So back to you, Shawn.
Thanks for that, Robert. I appreciate that. So let's take a look at what we have in the world. There are so many different multinational standards organizations that's available to us. It's really hard to know which one to follow. But what it really breaks down to is this. What is being called out, either by your own quality program, your customer, your vendor, or what is being specified to that particular product or test that is being conducted. This could be from product development to research and development. This could be in the private industry. This could be in the academic platform. There may not even be a standard yet available to you, and that can be extremely frustrating and difficult. I mean, when we think about it, standards have been around a long, long time. We're going to kind of touch on a few of these standards. We're going to keep it basically to two primary, which is ISO and ASTM. And ISO actually has been around since the 1920s. It took a small suspended break in the 1940s because of this thing called World War II. But after World War II, it was reconvened and became then the International Organization of Standards in 1947. Across the way in the United States, ASTM started in 1898 by a gentleman by the name of Charles Dudley. And if anyone has heard the term running off the rails, that's where it came from, or so fable would have that. He generated a group of engineers and scientists and individuals to help form what is now ASTM International. And not to be overlooked, the Bureau of Indian Standards was a founding member of ISO, the International Organization for Standards, in 1946. But for those of you who work in this area, you may have remembered the Indian Standards Institute, which preceded all of the standards as they started actually under the Society Registrations Act of 1860. That's a long time ago. There are so many different standards out there. And when we think about it, what can we do? How can we get to figure out what these standards are for, which ones we should follow? What I would recommend to you is that you get involved in any of the numerous standards in the multinational committees that are available to you. This will put you in contact with colleagues, maybe some competitors, who you can communicate with immediately at these standards committees without bias or prejudice. You can get immediate feedback. That's invaluable. These are not commercial platforms. And from my point of view, I really want to put this out there. We all have family members. We all have friends and people that we spend time with, that ride on planes, that cross the bridges, that go up in the skyscrapers. Standards really dictate how all these things are tested. The chairs that we're sitting on today, the screens that we're looking at, all these things are tested. And thankfully, they're all tested under these multinational standards that we're talking about today. It's good to know that we have the power of standardization behind all these developments, at least in my opinion. We're going to ask you a question now, so I'm going to pass that off to Jenny. Okay, welcome back. Hopefully we've given everyone a chance to answer the question. And let's just take a look and see what we have. It looks like we have about a split. About 50% of the people think there's less than 100, and 50% of the people think there's more than 100. But if you think about it, there's definitely more than 100 organizations, because we're also talking about international standards, the country standards, regional standards, municipal, city, military, or any combination thereof. And we have to ask ourselves, which one do we follow? That's difficult, right? But I would implore you to follow the ones that you're familiar with and communicate with your folks that are doing the testing to which one you're going to use. Excuse me for just a moment as I look through this. We had 8% think there was 1 through 20. I've got the final poll here, and that's what I was waiting for. We've got about 10% that think there's 21 through 50. We have 30% who believe there's 51 through 100. And we have 51% who believe there's 100 plus. The answer is 100 plus. That's a lot of organizations to sort through, I would think. So let's move on. When we're talking about materials testing and what's happening in the world of it, for this particular presentation, what we're talking about is destructive material testing. There is also non-destructive, and there's so much that happens in this dynamic cycle between the raw material being produced, the testing that happens with it, the product testing. It can go in any direction, as you can see by this slide that's in front of you. And it can cycle back and forth before it finally makes it to final market. And even then, it's tested. I mean, for those of us in attendance, think how many times you've had to test a final product. And then if you think that's only the place it's being tested, you're probably wrong. It doesn't mean that you don't know. It's just that we're so many different layers to the testing world, specifically for materials testing. It's unbelievable at times. There's so much to think about here, right? There's so many things that we consider when we're doing our materials testing. We have to ask ourselves, is this what we need to do? Is this what the customer is asking for? Is this how I'm going to complete my project in the university or in the college? What do we have to do? So what is material testing? We ask ourselves, in the destructive world, it could be a tension test, a compression test, a bend test. It could be hardness. In the concrete world, there's a number of different types of tests. We test asphalt. Heck, we test the buttons that are on our shirt. We call that a stress test sometimes if we've had too much to eat. Of all the time that I'm going to focus on this, it's primarily going to be on destructive testing. And I like that. I get paid to break things for a living. So I would say that's a pretty good occupation. I was told I would never get paid to break things for a living, but my mom, she was definitely wrong. I would have to say there's also many different types of those destructive tests, which brings me to this one point. And I want everyone to think about this. There are times when we do not want to damage the material or the end product permanently, and that would be non-destructive testing. So again, I would ask you, we're going to put out another question to you. This is about hardness testing. Is it destructive? Non-destructive? Is it both? Or is it neither? And Jenny, I'm going to ask you to put that out. You have. Great. Thank you. And I'll give it a few minutes and I'll just mute myself while we wait. And if anybody has any thoughts on this, at the end of all of this presentation today, we will have a question and answer period. And we'll also give you lines of connections to communicate with Robert and myself. Well, I think we have a pretty good cross-section of answers here. And just in a nutshell, as we look at this, we have about 2.5% of the folks of the audience that think this is neither destructive or non-destructive. We have about 32% that consider a hardness test destructive. We have about 14% of the audience that believe this to be non-destructive. And we have about 51% of the audience polled believing that this is a destructive test. Or excuse me, both. Apologies for that. And the answer is both. And the reason it can be both is because hardness can be derived through NDT testing or non-destructive testing. And there's a number of different ways to get into that, but I think that's for a different seminar or webinar, if you will. But the most common known destructive testing would be the Brunel, the Rockwell, the Knoop Vickers test, micro or macro, and any loads that go all the way up to 3,000 kilograms and all the way down to just fractions of a gram, with different size indentations and how to measure that deformation. And it's a very dynamic world in the world of testing and hardness testing, and it's incredibly complicated to decide what standard to follow. But they're out there, either in ISO or ASTM or any other number of standards. So let's move forward a bit here and get to one of the reasons that you're here. What are we looking at here? We're looking at breaking things. One of the favorite things that I have in my life. I would say that my children believe that too, that they think they might be able to just break things and get away with it. So let's talk about destructive testing and how we conduct this destructive testing. What we're looking at on the screen here is some cutting edge technology. We're looking at some non-contact extensometry. This is sometimes called a video extensometer or an optical non-contact extensometer. And they do the same things that contact extensometry have done for over 100 years. but they do that with today's technology. If you really think about this, it's pretty amazing that we can read the physical properties with virtual strain gauges through the algorithms in the computer programs, in the hardware that you're seeing on the screen there. We at Tinius Olson use a particular type of software to read the input from these two types of devices that you're seeing on the screen. But at the end of it, what we're reading is the same thing that you would see on a contact extensometer. We've just come up into the future. Now, these optical extensometers that you're seeing, they've actually been around for about 70 years. They were very rudimentary in comparison to today's standards. And for those of us who've been testing in the testing labs for a number of years, we can all relate to the unfortunate situation of breaking a sample with a contact extensometer on that. So what I just told you is that we just saw an example of non-contact extensometry. And just a couple notes of interest. Just 20 years ago, about 90% of the extensometer applications were full physical contact extensometry. We'll see that in the next slide here coming up. But fast forward to today. The year is 2020. And now about 70% of the extensometry is just contact. And the other 30% is non-contact. That might not sound like a big jump, but it is. And there's a problem with that. How do we address this in the standards of today? Can you imagine a room full of engineers and scientists and physicists and individuals from the Society of Testing talking about this new application or what we perceive to be new? And everybody has different language, different terminology for their particular device. How do we get that so that we're all on the same page? If you're wondering what I'm going to say, or you've already guessed it, it's standards development. The standards give us a boundary, if you will, a guideline, a way to follow through. It's what we use to standardize what we're all doing in this wide world that we live in. It's amazing when you think about it that the first extensometer was similar to what you're seeing on the screen. It was invented by an individual by the name of Charles Hudson back in 1879. So stop and think about that for a while. 1879 was the first extensometer, and it was presented here in Philadelphia at the Franklin Institute here in the United States. But here is the unusual thing. Excuse me. E83, which is the ASTM standard for extensometry, didn't address this until 1950. Now, I wasn't around in 1950, but my guess is they couldn't figure out how to standardize all the things that we just talked about. The terminology, the application. Can you imagine a room full of individuals who are very, very intelligent, all trying to agree on the same exact thing? We can only look around our world right now and see all the arguments and disagreements that we have about what is right and what is wrong to imagine what it would be like in these rooms. But it's exciting. It's invigorating, and you'll hear things that you've never heard before. Or you may come to one of these meetings with an idea and realize that one of your colleagues from across the world had the same idea, and you can collaborate with them. We can do this to make the world a better place. I truly believe that. When we think about what we have to do and how we have to get these things into the world of testing, into the society so that we have a better mousetrap, if you will, a new widget, a new device that honestly was better than what we had already. How do we do that? And although I've isolated ASTM and ISO primarily in this presentation, they all work fairly similar. They have a very clear and concise pathway to getting a new product or test platform or R&D project or an academic white paper into the standard. And we can all benefit from that, right? We can all find something new, but you have to get involved. So let's stop for a minute and let's fast forward to what we're talking about. What's ahead of us? I mean, when we look at this screen and we see the future, right? We see what's coming to us. And where do we hear about that? What do we find when we go to these meetings and we talk at the universities and we talk to our colleagues? I've seen some pretty amazing things and heard some pretty incredible ideas. And more often than not, I've heard these at the sittings of a multinational standards committee. A lot of times, much before they actually made it to a concept or a model or a design, and definitely before it made it into the society. It's talked about at these international standards committees. So there's a number of ways that you could be at the forefront of this. And in a few slides, we're going to talk about that. You're going to watch a video about how you can get involved, what you can do, what direction you can take. And remember this, no matter if you're in Zimbabwe or the Ascension Islands or in India or any part of Asia, no matter where you're at in the world, there is a standards committee that can use your particular vision, your desire, to make our world better. I know we can do this, and we can do this together. I want to take a moment to talk about technology and the future and what is right now. What you see on the screen that you're looking at has been developed and worked on for a number of years already. But there was a problem. There was no standard for the exosuits and the exoskeletons. But there is now. But it's just in its infant stage. So we need the folks that are behind these unbelievable technological advancements to become involved so you can share with your colleagues, your coworkers, and everything in between your ideas, your thoughts. What is safe? What isn't? What's right? What's wrong? It's a healthy conversation, right? What we want to do is the right thing. Can you imagine a child who unfortunately doesn't have the capability to walk on their own, but with this futuristic technology, they can? We have that capability, and we can drive that through international or multinational standards development so that we all talk about the same thing. I think it's incredible that we have this platform today to talk to all of you, and I can't wait to get the questions at the end of this particular session. I think it's going to be incredible. You're going to ask a bunch of questions that I hadn't even thought of. This is incredible. And again, thank you. I'm going to pass this on to my colleague who's across the way, who can talk a little bit about what you're seeing in front of you. Go ahead, Robert. It's all yours.
Thank you, Shawn. Right, following from Shawn's outline of testing as he sees it, I'd like to give you a brief view of my work on the BSI TCI 066 Safety of Children's Clothing Committee. It's a committee made up of representatives from the test industry, fashion, department stores, safety, consultants, and so forth. The majority of whom are ladies who've worked in this field for many years now. As a design engineer, it's not really an obvious committee to sit on. I joined as the third in line of Tinius Olsen employees. It's not a natural fit, but I'm told my presence is appreciated because, in their words, I know nothing. This isn't an insult, it just means that I question everything and add a different perspective to things. Children's clothing encompasses ages from 18 months to 14 years, 364 days. Whatever the current fashion is, it can be found replicated in scaled-down form. There have been many heated debates as to whether features are functional or embellishments and whether they pose risks. Disguised costumes is an area with crossover into the toy standards. These constitute clothes which allow children to pretend to be their favourite characters. These costumes are often made in ways so that they can be worn over existing clothing. These costumes are often existing clothing. They may have quick access designs, but also have potential for being entrapment. Consideration must be made as to whether the child will be supervised in play or left to their own devices. The committee covers the UK, but is also part of CEN, the European Committee for Standardisation. Trying to find a common language that allows you to convey ideas across so many countries can be challenging. Commonplace names so familiar to us must be redefined into more generalised descriptive terms. There are many different views across the European Committee as to how things should be approached. It is the view of one country that all hoods should be removable. The hood offers an entrapment hazard and could result in choking if the child can't free themselves. Contrary to this, there are many examples of children who have been saved by parents grabbing the hood and pulling the child to safety. Whilst the hood issue was being discussed, I was reminded of a tragic instance. It highlighted that equipment in the right context saves lives, but incorrectly used can cause harm. A child was cycling and wore a cycle helmet. She stopped to climb a tree, and the helmet became entangled. As a cycle helmet, the primary function of the straps was to resist the helmet becoming detached. Right, Shawn, back to you and the video, thank you.
Thanks so much for that. I appreciate that, Robert. As you can see, and we talked about before, testing covers everything. Everything that we touch, everything that we look at, everything that we stand on, the planes we ride in. It's amazing when you stop and think about all the different testing standards that are out there. I can only imagine about how many of them I do not know of. In my particular circle of expertise, there are over 2,500, that's 2,500 isolated standards specifically for destructive mechanical testing. I don't know all of them, but I sure know where to get the answers about them. And so what we're going to do now is we're going to just take a couple minutes to watch a video so that we can all see how that's going to work, how you can get involved, what you can do to make a difference. So if you can, just take a few minutes, watch this video, and let me know what you think. You can send it to us privately after the meeting. If you have any questions about it, let us know. If you need some direction, I'll do the best I can to find you the answers. I'll work with Robert and the rest of our team at Tinius Olsen to do what we can to answer your questions. We'll see you in just a few moments.
Members are so important to ASTM International. Without our members, we don't have the contributions that are necessary to develop world-class standards. ASTM membership is driven on an individual basis. Those individuals represent different companies, different organizations, government agencies.
I think the fact that every member has a voice is something that makes ASTM truly special in the standards development community. Whether you're representing a Fortune 500 company, whether you're representing a small and medium-sized enterprise, whether you're a consumer that's bought a toy for their grandchild and wants to participate in the development of our toy safety standard.
Everyone's voice is just as equal as anybody else's. It's really helpful because it's really good to have everybody speaking the same language.
Being involved with ASTM has really helped me professionally, meeting people. A lot of them are my customers, competitors, users.
Having the networking, connecting at the ASTM events really makes it seem like a community.
You may think you have an idea that may work, and you can bounce it off your colleagues at ASTM, and you can get direct, immediate feedback.
The cost of being an ASTM member is low. It's $75 per year.
Because our philosophy is that the more inclusive our standards development process is, the more technical quality the standard is going to have, the broader its application and use.
I would tell anyone who's considering joining ASTM that they should definitely participate, become a member, go to the meetings. Once you get a good feel for how important it is and how informational it is, it's paramount to the careers of individuals who work in standards.
There's a lot of benefits that our members receive. It's an extended network of industry professionals. It's training opportunities like symposia, workshops where you're learning cutting-edge technology.
Participating in the ASTM process exposes you to the people who are trying to use these systems, and you get an idea of what the real-world problems are. And so you can go back to your lab and work towards solving them.
Do I encourage people to get involved in ASTM? I can say with a resounding yes.
If anybody was on the fence about joining ASTM, I would tell them don't hesitate. It'll help you advance your career.
And as members stay with ASTM, what's really great is that they see how the consensus process works, and it becomes a collective mission for all of us to help our world work better.
And I'm back. Thank you, everyone, for taking just a few moments to watch that video. I think we can all agree that we could all find a new way to get involved if you're not involved already. And for those of you in the audience that are already involved in these standards committees throughout the world, thank you. Because without you, we wouldn't be where we are today in the world of testing, regardless of whether it's robotics, AI, the academic world, the research and development, destructive and non-destructive testing. We all can utilize standards and what's happening today to make the world a better place. Well, we're getting to the point of this particular webinar where we're going to talk about questions and answers. And if you haven't figured it out already, you'll probably tell by my presentation that you can normally find the answers in any number of standards available to you, regardless where in the world, what language you speak, what project you're working on, what university you go to. You can find them in some form or fashion in one of the multinational standards. Now, I don't have all the answers, but I do believe with this type of platform, with those in attendance, today we can use the many different resources available together to get these answers. I want to thank you again for your time and your attention and your participation. Feel free to reach out to us. Let us know if you have any questions. Like I said, we don't have all the answers, but we definitely know where to go and what resources to use to answer your questions, your concerns, or just to address some of your comments. I'm going to go back to the previous slide and let you know that we're willing and ready to take some of your questions. Bear with me for a minute as I review a few of these questions and see if I can come up with some answers for you. And a lot of the stuff we might have to take offline. But I'm going to go to an individual from Tata Steel, and I'm going to approach this question and see what I can come up with. And the question is, how do we determine the impact properties of carbon steel sheet material having a thickness of only 2.5 millimeters or below? What drives that? Well, I'm going to tell you the answer is in one of the standards. It's either an ASTM E23 or ISO 148. And we can talk a little bit more about that offline. I appreciate the question. I see that you go by Nosh, and thank you.
Right, Shawn. I'd like to deal with one of the questions that came in, which was regarding basically the fireproof rating of cheaper children's clothing.
Well, give it a go. I'm going to mute myself and listen to your brilliance.
It's like all things, unfortunately. The standard only works for the people who adhere to the standard. So, for instance, in terms of dressing up clothes and all the rest of it, the major companies, such as, say, Disney Store and others like that, they would and do adhere to the standards. But there are many companies which make rather cheaper copies of the same products and release them into the market, and they may not be to the same quality and standard. So, unfortunately, it is buyer beware to a certain extent. If it seems too cheap, it probably is too cheap, and you may be putting yourself at risk, unfortunately. I hope that answers the question.
Well, thank you very much for that, Robert. When we go back to the presentation, after we get done with this question and answer period, we're going to put our contact information so that you can talk to us directly. And then you can expect to get some feedback from us over the next few days in some cases, and sometimes it may take a few weeks. Thank you very much again, Robert. I'm going to go down through a few of these other questions and just kind of answer them as quickly as I can, and so that we can see what we're kind of circling around on. This question is from Nikki, who is a material scientist and a QA engineer. And what Nikki asks is, should design authority decide which standard to apply, and it should be stated on the drawing? Excellent question. And the answer is, it depends. If your particular design has been accepted and has been vetted and follows the standards, then I see no reason that you could not state what your requirement is in reference to a standard. But again, that is what's known as the decision rule between you and the particular end user or vendor. I hope that answers that question. Feel free to reach out to me, Nikki, privately. When you get to my contact information, we can discuss that more. And we can also discuss your other question as well. I see you have 2 or 3 questions. Daniel. Daniel is asking a question. He's from Explio. And his question is, do ISO and ASTM collaborate, or are they totally separate organizations? That's a great question. And thank you for bringing that. That question is asked numerous times. And yes, we do collaborate. There's actually representatives that attend the ISO meetings from ASTM, and there's individuals from ISO that attend the ASTM meetings. And there is a particular committee that talks about the marriage, if you will, between ASTM and ISO. What we try to do in the standards committee is try to make sure that we're not in competition with each other, because we're not. What we're trying to do is give direction to the society of testers, engineers, scientists, physicists, so that they have some boundaries, some guidelines. And if you were to look at any of the number of standards throughout the world, they're all formatted fairly similar, and that's by purpose, by design. So excellent question. Thanks for that. We've got a question from a colleague, Dan Ditzler, and a friend. Thanks for that question, Dan. And it's an excellent question at this point. In the time of the pandemic, do you think there will be an increasing push for materials germs resistance? And I can answer that with a resounding yes. Currently, there are a number of different platforms that are pushing for different types of materials that could be utilized that may have an effect on the resistance to particular germs. That is an incredible question. Thanks, Dan. Let's go to Alfred from Safran Electrical Components. For gauge R&R studies on tensile test machines, is there a standard in other than the measurement system analyst booklet of, well, I can answer you real quickly on that. Alfred, there is. And I would implore you to reach out to me through the connection that I'll put up on the screen here directly, and I can give you some guidance on that. I have quite a few different resources that we can talk about. Thanks for the question.
Right, Shawn, can I just jump in quickly on one of the questions here?
Absolutely.
The question.
Give it a go.
The question is from Nikki Bradford, and it says, what about applying standards with 3D printed parts? I don't know if there is a standard for 3D printed parts. It is something that I have some experience of in terms of we use 3D printers to generate prototypes and various parts and little test fixtures and all the rest of it. It would be a very difficult standard, I feel, to actually come up with quantitative results, because a lot of 3D printing is purely space models and function and to conceptualize and to see things, whereas other 3D modeling can be metal components and can be completely functional. So it would be very difficult to apply a standard only to 3D printing. I guess we would then have to go back to taking sections out of it and apply good old-fashioned ASTM E8 or any of the other metals or plastic testing standards. Hope that helps.
Thanks for that, Robert. And to dovetail off that answer, Nikki, the answer is not just along the lines of what Robert's telling you, but let's stop and think about that a little bit. 3D products are relatively new to the society of the world, specifically on testing platforms. And they are being tested, but a lot more research and R&R in intra-laboratory and interlaboratory studies need to be done. What we're finding is that normally the manufacturers are following what's already involved in the standards, as Robert was alluding to, the ASTM E8s, the ISO 6392s, etc. But that was an excellent question. We can talk a little bit more about that offline. I want to get over to a question that I get asked quite often. And this question is from Roman. How long does it take to develop a new standard for a device manufactured for some kind of new testing? That is an excellent question. And Roman, thank you for bringing that. I've been involved in ASTM standards and standards development on a number of different arenas. And I'm here to tell you there is no timeline. With some products, it can be accelerated. And in the world of standards development, that means within a few years. If it's an improvement on a design, or if it's a design that the concept has existed. But as I was showing in my presentation earlier, in the presentation that Robert and I worked on, if you looked at the extensometer, it didn't make it into a standard for 70 years. Now, that was at the infancy of standards development, if you will. And that doesn't take that long, thankfully, anymore because of the technology such as what we're using today. We can reach out all over the world without even being in the same room. But nothing, as far as I'm concerned, beats good old face-to-face sharing of ideas across a cup of tea or a cup of coffee or whatever your proclivity of beverage may be. So to answer that question, Roman, I don't have a definitive answer. But I can tell you in the world of testing that it's very, very dynamic. The world of CPM or crucible material has been around for a while, and now it's actually addressed in particular standards, specifically of destructive testing. So hopefully that answers part of your answer. Feel free to reach out to me privately through the contact that you'll see on the screen here shortly. Thank you again. I'm going to address another one that's in my arena, if you will. And that question is from, let me take a look at this, an engineer from TSSIMIL. I'm not quite sure, TS, I believe. How do you calibrate a non-contact extensometer? Excellent question. And you calibrate it just like you would calibrate anything else in the same arena with a standard. And if you have a defined standard that has a set distance, because really all you're looking at is displacement or movement, if you will. So if you have a known standard, which the manufacturers that are out there can produce for you, or you can set your field of view to focus on a known distance to target with a extensometer calibrator in the view of your non-contact extensometer, you can calibrate it pretty much the same way you would calibrate a contact extensometer. And if you'd like to talk about this a little bit more, I can drive you to the particular standard in ASTM E83 that discusses this. Thank you very much for that question. I appreciate that. I think I'm going to answer one or two more questions. And Robert, if you have any questions that you see fit to answer, let me know. I think I'm going to pick one more. This one is from Kristen Parisi from Boston Scientific. And the question is, if an ASTM standard prescribes some dimension for a specific, If an ASTM standard prescribes some dimension for a specimen that are not achievable with the technology you are using for your product, can you test a smaller specimen according to the standard? Kristen, it depends. And what it depends on is what your agreement is between either you and the end user, because that can override a portion of the standard. and if it's agreed upon between you and either your end user or your vendor. If intrinsically you cannot meet a particular dimensional requirement, then that is something you definitely should bring up to ASTM. Sometimes intrinsically something is designed and it's almost backbreakingly laborious to get to those particular dimensions, and I can talk about that firsthand a little bit more. I want to thank everybody for all your questions. We've got so many, so much great feedback, and I can't wait to go through all of these and work with Robert and the rest of the team at Tinius Olson. And I want to take this opportunity again to thank IOM3 and WorkCast for allowing us to present on this platform. Thank you all so very much. I'm going to get back to the presentation and put up our information so that you can look at it, take the information down, and reach out to us when you see fit. Thank you all very much. I want to thank you again from the bottom of my heart. Be well, be safe, and make sure that everybody around you knows that they can make the world a better place through standards development. Thank you once again.